Today we're going to be looking at the periodic table, and most specifically we're going to look at different ways to organize or divide up the periodic table to be able to understand it better. The periodic table, as you know, is made up of 118 elements, the 118 that have been discovered to this point. There are a lot of different ways that we can group these 118 elements in order to talk about them and without having to list every single one of them. We can divide them into blocks. If you look at the periodic table that's on the wall in the classroom, they have blocks labeled. There's an S block, a P block, a D block, and an F block. There are certainly similarities between the elements that are in a particular block, and so it's a good way to be able to talk about the elements. However, another way that we could talk about them is also the periods that are on the periodic table. In other words, it's the rows that go across the periodic table. There are some similarities between the elements in each row, although not nearly as much as there are in the blocks. A third way that we could divide up the periodic table is by groups. The groups of the periodic table are the columns that are in the periodic table. There are a lot of similarities between elements in each of the groups. The last way, and the way that we're really going to focus on, the last way to talk about the periodic table and to kind of divide it into sections is by family, and we'll be taking a look at that. Now, in the rest of this video, you're going to be doing a lot of both fill in the blank and coloring as well. So you're going to want to make sure that you have the periodic table that was handed out to you and the fill in the blank notes in front of you, because we'll be working with both of those. You'll also get some colored pencils to use along the way as well, because we'll be color coding our periodic table. Let's go ahead and start by looking at your periodic table, and we're going to start by numbering the periods. There are 7 of them. Again, these are the rows across, and so we're going to number those down the side. There are, as I mentioned, 7. The lanthanides and actinides are not numbers 8 and 9, because instead they are actually a part of periods 6 and 7. We'll talk about that a little bit more another time. Go ahead and pause the video as you label your 7 periods. Next, you're going to label the 18 groups, in other words, the 18 columns of the periodic table. The lanthanides and actinides technically all belong in group number 3. We'll go into more detail about this at another time, but for now, go ahead and pause the video so that you can label the 18 groups along the top of your paper. The next thing we're going to do is simply draw a box so that you can have a key for your periodic table. We are color coding, so you need to make sure that you have a key. You can put the key where they have located it here, or there's space at the bottom of your page as well, and you're certainly welcome to put the key there. Go ahead and pause the video so that you can make the box for the key. All right, so the first of the color coding that we will do is what we call the alkali metals. You're going to need a red colored pencil, and you're going to shade in all of the elements of group 1 except for hydrogen. Do not shade in hydrogen, but you are going to shade in lithium, sodium, potassium, rubidium, cesium, and francium. Go ahead and pause the video while you shade these in. All right, we're going to switch now over from the periodic table to your fill in the blank and talk just a little bit about these alkali metals. Typically, when we think of metals, we think of substances that are pretty hard, generally pretty shiny, but pretty strong for the most part. However, alkali metals are different. They are shiny, like a lot of other metals, but they are quite soft. Another interesting thing about them is that they are highly reactive with other elements. They have just one electron in their outer shell, and because of that, they want to get rid of that one electron. Atoms are not typically happy having just one electron in their outer shell, and they would just as soon give that away to another element that is looking for an extra electron in their outer shell. And so when they give it away, so to speak, a chemical reaction happens, and in the case of alkali metals, it can often be pretty violent. These alkali metals can be cut easily, and in nature, because they tend to react so much with other elements, they are never found all by themselves. They are always chemically combined with other substances in nature anyways, and we call those different kinds of salts. The salt that we're most familiar with, of course, is sodium chloride. So sodium, which is one of the alkali metals, chemically combined with chlorine. Of course, this is table salt, and we've talked a little bit about sodium chloride in the past. Soon we'll watch a video that shows just what happens when you combine sodium and chlorine. We did see a little bit of that actually in the Hunting the Elements video. We're going to take a look at another kind of close-up example of that later on. All right, the alkaline earth metals are next. We're going to color these dark green. So go ahead and make sure that you get a dark green colored pencil. And the alkaline earth metals are all found in the second group, in group 2. And it is all of the elements that are in that group. So go ahead and pause the video while you color those in. All right, we're going to switch back again to the notes page and talk just a little bit about the alkaline earth metals. Again, these are different from the metals that we typically think of. It's not, like the metal that makes a paper clip, or the metal that makes a steel rod, or even the metal that makes up wire. Instead, these metals, they again are shiny, like most metals, but they have kind of a silvery white color to them. They are fairly reactive with other elements, not as violently reactive as alkali metals, however. They have 2 electrons in their outermost shell, and again, typically an atom would prefer to have 8 for the most part in its outermost shell. That does vary a little, but 2 is typically not the number that an atom would like to have, with the exception of helium, which we'll talk about later. So those 2 outermost electrons, they would again just as soon give away or share with another atom, and so when that happens, there is a chemical reaction that happens. These metals have quite a low density. Typically metals are pretty dense. These are less dense than other metals. They also have a low melting point and a low boiling point. All right, the next set of metals that we're going to take a look at are the transition metals. All right, these metals we are going to color a light blue, And so go ahead and make sure that you get a light blue colored pencil. Now this is the largest group on the periodic table, so this is probably going to take you a little while to fill in and shade in. So make sure that you are recording these in your key. You should have 3 things in your key so far. And go ahead and pause the video as you fill in the transition metals. All right, so a little bit about the transition metals. These are kind of the metals that we think of when we think of metals. They are basically all what we call malleable and ductile. So malleable means that they can be pounded out. They can be pounded even into a sheet, like similar to aluminum foil. Aluminum foil is a sheet of the metal aluminum, and the fact that we can make aluminum into a foil like that shows that it is malleable. Ductile means that it can be stretched out into a wire. Think of copper. Copper is often made into wires, so copper is a very ductile metal. It can be pulled out into a wire shape. All of these metals are very good conductors of both heat and electricity. Heat and electricity pass through them very well. They are very dense. This is different from the alkaline earth metals. These transition metals are very dense. Again, this is what we typically think of when we think of metals. They have a high boiling point and a high melting point. There is a little bit of an exception to this because the metals in group 12, they tend to have a little bit of a lower boiling and melting point than the others. And you even have a couple of elements there that are liquid at room temperature. After each of these sets of notes, if you need to pause the video to finish filling in information, feel free to do that.